Welcome class to today's lesson. We're just going to talk about periodic trends in today's lesson. Those things that you see, those little patterns that you see when you look at the periodic table and trying to come up to some understanding about those patterns. We're also going to talk about the factor that the laws of attraction and repulsion play when we talk about the periodic table and how they change atoms in terms of atom size and reactivity and so on. We're just going to go back before we go forward. We're very familiar with this thing of beauty, the periodic table, as devised and conceptualized by Dmitry Mendeleev. The periodic table, of course, you're well aware at the moment, already has many trends built into it. One we know of as you move down a group, you move down from top to bottom, and you move down that group. We add more shells. The number of valence electrons on the outside doesn't change. So in this case, we have 1, 1, and 1 as we move from hydrogen to sodium, but we're adding electron energy levels each time as we move down. The second thing that we could and have talked about in the past is what happens as you move across a period. As you move across a period, each time, of course, 1 electron is getting added. And in this case, the number of shells is not changing, but merely 1 more valence electron is getting added each time. So the first thing that I want to talk about is the concept of atomic radius. It's the distance between the atom's nucleus and its outer electrons. And you can think of this as the radius of a sphere or a circle. And it increases as you move down the group. It increases as you move down. And then it decreases as you move left to right. So it's actually increasing right to left. The reason why it increases as you move down, the radius increases, is, well, the new energy levels are added as you move from, let's say, hydrogen to lithium to sodium, and that's going to increase the actual radius of that sphere or that circle. That's a little bit easier to understand than discussing as you move from left to right. So as you move from left to right, from, let's say, carbon to fluorine, the number of energy levels isn't increasing, but the main reason why the radius gets smaller is because as more protons are added, the nucleus itself becomes much stronger, becomes a stronger beast. And because of that increased charge, the force of attraction, electrostatic force of attraction between the proton and the electron in fluorine is much stronger than it would be in carbon, and so it tightens the atom, and the atomic radius gets much smaller as you move left to right. The next thing that we're going to talk about is the concept of ionic radius. So we also have radii when we're talking about ions, and if we look at maybe chlorine, when chlorine gains an electron, it becomes Cl minus. Now, as it gains an electron, its ionic radius actually increases, and the reason why it increases is because of these increased number of electrons. The electrons in the outer shell, they would repel each other due to those electrostatic laws, and this will cause the outer part of the chloride ion to increase, if you like, and so the ionic radius is bigger. If we look at something like sodium, when sodium actually more often than not loses an electron, it will become sodium plus, and the ionic radius actually decreases because it would drop down to the energy level, energy shell below that, which would be full, and it would mimic the behavior of neon, which sits 1 proton less and 1 shell less than the sodium atom. Next thing that we're going to talk about in terms of trends is ionization energy. This is the energy required to remove an electron from an atom or molecule. And you can see that the ionization energy, it could be related to a scenario where you're trying to take a handbag from a person, and maybe you think that it's a certain amount of energy required for that, but turns out that you need quite a little bit more energy than you first imagined. Well, as we move down the periodic table, what happens is, in terms of ionization energy, is that the amount of energy required to remove an electron decreases. And the reason is, as you move down the group, is there is less force of attraction between the protons and the electrons. And the reason is because of all these extra shells. And what they do is they provide what's called shielding. So they shield the outer electrons from the nucleus, and so it's much easier to remove those outer electrons when there's more shielding and shells between it and the nucleus. The ionization energy increases, however, though, as you moved towards the right, as the force of attraction between protons and electrons increase. And that is because of there's a bigger nuclear charge. So we have more protons, as we talked about earlier, as we move from carbon to fluorine as an example. And therefore they would be more tightly packed, tightly bound. It's much more energy is required to remove those electrons. So if we want to look at the general trend, it actually increases as you move up and to the right. So this one is the opposite of atomic radius, which increases as you move down and to the left. The other thing that is worth mentioning about ionization energy is that there are multiple ionization energies for different elements or atoms. And you'll see that more energy is required to remove that second element than the first. So I1 is for the outermost electron, I2 is for the two outermost electrons, and so more energy is required to get that second energy off. You'll also see that as magnesium, if we take magnesium as an example, there's a big jump as you move from I2 to I3. Well, the reason is I2 has removed that second electron, and it's become Mg2+. Now, to remove any more is going to be very difficult, because it essentially now is a noble gas, and it's got a full outer shell, and massive amounts of energy would be required to remove that. The same if we look at aluminium, and the same if we look at silicon. We see those energy jumps because effectively they're acting like a noble gas in that case. Another concept that we're going to talk about is electron affinity, and this is the energy change when an electron is added to an atom. So not removed from an atom, added to an atom. It can be viewed as the opposite of ionization energy, if you like. And because of that, normally it's a scenario like this, where X represents the atom. An electron's added and it becomes a negative ion, an anion. But because an electron's been added, energy is usually released, and it's usually negative. Not always. There's exceptions to a lot of these trends. Around the noble gases would be an example, and we'll discuss those further in class. But usually the trend that we see is that it increases as you move up and to the right. So the same type of trend as existed in the periodic table as we saw for ionization energy. And finally, the last thing we're going to talk about is similar to electron affinity. It is called electronegativity. It is very important when we discuss bonding. We're going to talk about it in a large aspect. It's the ability of an atom to hold on to electrons. This gentleman here is doing a fantastic job holding on to the mosquitoes, and indeed attracting mosquitoes, if we could look at mosquitoes as electrons in this case. Some elements do a better job of holding on to electrons than others. And the general trend is that it decreases as you move down a group, and again that is due to shielding. When you're moving down from, let's say, lithium to sodium, there's more energy levels there, less attraction between the proton and the electron, and it doesn't hold on to the electrons as well as it would for lithium, for example, sodium that is. And it increases as you move to the right. So it's a similar trend as the last two, that is to say ionization energy and electron affinity, in that it increases as you move upwards and to the right on the periodic table. So the general trends, as already discussed, as you move upwards and to the right, certain things increase. So ionization energy increases, electron affinity increases, and electronegativity increases. However, the atomic radius increases as you move downwards and to the left. So that was a brief introduction to some of the trends that we see in the periodic table. We're going to continue with some activities and discussion tomorrow.